In exercise 1, we need to determine which matrices are in reduced echelon form and which others are only in echelon form. We know that a matrix is in echelon form if it is satisfy all these three properties, but it is in reduced echelon form if it is satisfy all these five. So 3 properties for echelon form and all 5 properties for reduced echelon form. So for the first matrix in A, it is clear that it is in echelon form, plus it satisfies these two properties, so that means it is in reduced echelon form. So the matrix A, it is in reduced echelon form. For the second matrix, which is B, also it is clear that it is in echelon form because it satisfies these three properties. Plus, also it is in reduced echelon form because it satisfies these two properties. So A and B, both of them are in reduced echelon form. For C, it is clear that satisfy property number, does not satisfy the first properties, which is all non-zero row are above any row of all zero, because here we have zero row, which should be the last row, but here it is clear it is not the last row, so we conclude this one is not in echelon form. The last one, it is satisfy the first three properties, but does not satisfy the property number 4, because it says the leading entry in each non-zero row is 1. Here we have the leading entry is 2 and the leading entry here also 3. So this one is only in echelon form. echelon form only. يعني نحن نقول إنها في الإشلون فورم إذا حققت الثلاث الخصائص الأولى. إذا حققت الخمس خصائص كلهم مع بعض نقول reduced echelon form. إذا واحدة من هذيل الثلاث أول ثلاث ما satisfied إذن على طول نقول it is not in echelon form اللي هي نفس part C. فما يحتاج نسوي تشيك هل هي في reduced لا. طالما هي not in echelon form إذن طبيعي بتكون not reduced also. In question number 3, we need to row reduce the matrices in this exercise to reduce echelon form. Then we need to circle the pivot positions in the final matrix and in the original matrix and list the pivot columns. So first we need to row reduce this matrix to try to put it in the form which is reduced. So let us do some row operation to reduce this matrix. So after reducing this matrix, we will get the new matrix which is in reduced echelon form, which is this one. So this is after doing row operation. We have changed row 2, here we change row 3, then row 2, row 1, and row 3. So the final result is this one. So we need to circle the pivot position in the final matrix. So this is the pivot position. And here we have another pivot position. Only we have two pivot position in the final matrix. Also we need to circle it in the original matrix. So here at 1 and at 5. Since we have a pivot position in the first column and in the second column, so here we will say that column 1 and 2 are pivot columns. So we have two pivot positions, that's mean we have also two pivot columns. In problems from 7 to 13, we need to find the general solution of the system whose augmented matrices are given in exercise. So here we have an augmented matrix. We want to transform this one to reduce echelon form. Then we want to write or to find what is the general solution of the system. So let us start by doing number 7. Here we have this augmented matrix. We need to row reduce it to the other form. So for 7 now we get this after doing row operation. We do one row operation. Row 2 is equal row 2 minus 3, 1. We get this matrix. Then we make row 2 is equal minus row 2 over 5. We get this matrix. And the last one is row 1 is equal row 1 minus 4 row 2. So now our matrix is in reduced echelon form. We want to write the general solution. It is clear we have here two pivot positions. The first one is here, the second one is here. So from here we see that x1 plus 3x2 is equal minus 5 and x3 is equal to 3. So from here it is clear that x2 is free variable. So we have two basic variables, which is x1 and x3. We have one free variable, which is x2. So to write the general solution here, so the general solution is equal, we write x1 is equal 3 minus 3, sorry, x2 minus 5. x2 is equal x2 because it is free, and x3 is equal 3. So this is the general solution for question number 7. Here we can add 3. So that's mean we can substitute any value for x2. Now let us do the same row operations also to reduce number 9. So the first step, we interchange between row 1 and row 2. Then we make row 1 to be row 1 plus 2 row 2. So now we reach to the reduced echelon form. So from here it is clear to write the general solution. So x1 minus 5x3 is equal 4, and x2 minus 6x3 is equal 5. So it is clear that x3 is free. So to write the general solution, x1 is equal 5x3 plus 4, x2 is equal 5 plus 6x3, or let us write it as 6x3 plus 5. So here we have 6x3 plus 5, and we know that x3 is equal x3, that means it is free variable. So this is the general solution for number 9. Now let us see what is the general solution for 11. We need to reduce this one to reduced echelon form. So row 1 is equal 1 over 3 row 1. We get this matrix. Then row 3 is equal row 3 plus 6 row 1. We get this matrix. Now our matrix is in reduced echelon form. To write the general solution, so from the first row we have x1 minus 4 over 3 x2 plus 2 over 3 x3 is equal to 0. And from the second row, it is clear that all of them 0 and all of this 0. So the general solution from here, it is clear that x1 is equal 4 over 3 x2 minus 2 over 3 x3. x2 is free, so that means x2 is equal x2. Also x3 is free, that means x3 is equal x3. We can write it here, it is free, and this one also free. So this is the general must solution for the matrix, which is in exercise number 11. Let us do for number 13. So for number 13, we row 1 is equal row 1 plus 3 row 2, we get this matrix. Then row 1 is equal row 1 plus row 3, we get this matrix, which is in reduced echelon form. Now to write the general solution of our matrix, it is clear from here, the general solution, we have x1 is equal 3x5 plus 5, and x2 is equal 4x5 plus 1, x3 is equal, here we have x3, there is no pivot for x3, so that means it is x3 which is free variable. For x4, here we have x4 is equal minus 9x5 plus 4, and x5, there is no here x5, that means it is a free variable, so x5 is equal x5 which is free. So this is the most general solution for matrix which is in exercise number 30. So in exercise 15 and 16, use the notation of example 1 for matrices in echelon form, which is if we have this square, that means it is non-zero leading entry. If we have a star, that means any value including 0. So suppose each matrix represents the augmented matrix for a system of linear equations. In each case, determine if the system is consistent. If the system is consistent, determine if the solution is unique. So for 15a, we have this one is a non-zero leading entry, this one also non-zero leading entry, and this one is non-zero leading entry. For all these values, it could be any value including 0. So it is clear that it is in echelon form, but we cannot determine if it is in reduced echelon form or not. Because if it is in reduced, these all star must be, these 3 stars should be 0. But it could be any number including 0. So we cannot say it is in reduced echelon form. We say only it is in echelon form. The question asks us if it is consistent. Yes, because we have a pivot position in every column, so we can say that mean our system is consistent and it has a unique solution because we have 3 basic variables. There is no free variable. So for A, we can say it is consistent and a unique solution. We said if it is consistent, if there is no form which is the form 00b. We said unique if there is no free variable. So now B, it is, here we have a leading entry, here we have a leading entry, also this one is a leading entry, but here, because this one is 00b in the form of B, and here this one could be any number which is not 0, that means our system is inconsistent because this last row. So this one is inconsistent. يعني الأولى consistent لأنه أنا ما عندي الفورم 00b، لكن B في البارت B عندي 00b لأنه المربع هذا يرمز لأني non-zero leading entry. إذا non-zero، إذا أنا عندي هنا الفورم 00b معناته أنه السيستم is inconsistent. For number 16, this one is a leading entry, this one is a leading entry, and here we have the form 000, that means our system is consistent. It is clear that x1 here is a basic, x2 is also a basic entry, so that means we have, it is consistent and we have a unique solution. Although here we have 0, 0, 0, but we have only 2 variables because this is augmented matrix. This is represent x1, this is represent x2. So there is a value for x1, there is a value for x2, there is no free variable, although we have here 0, 0, 0. For B, here we have leading entry, which is non-zero. We have another leading entry, also we have this one is another leading entry. The system is consistent because we don't have a form 00b, so we can say here it is consistent. For the uniqueness, since here we have value for x1. For x2 there is no leading entry, that means x2 is 3. Here we have for x3, we have also for x4. So that means we have infinitely many solutions. So now for 17, we need to determine the values of H such that the matrix is the augmented matrix of a consistent linear system. So this is augmented matrix. We want to determine the value of H that makes our matrix is consistent. First, we need to row reduce this one to reduced echelon form. So here we can write 17. So the first row operation, we can make row 2 to be equal minus 2 row 1 plus row 2. The system to be consistent, it does not mean that it should be in reduced echelon form. It will be enough to make it just in echelon form only. So row 2 is equal minus 2 row 1 plus row 2. That will give us the new matrix, which is 2, 3, H, and here we have 0, 0, minus 2H plus 7. The matrix is consistent if we don't have the form 0, 0b. So that means minus 2H plus 7 must be equal 0 for the system to be consistent. So for the system to be consistent, we have minus 2H plus 7 should be equal to 0. That means our H should be equal 7 over 2. Because if this one is equal to any other value which is not equal to 0, that means our system is inconsistent. And in our exercise, we ask to find the value that make our system consistent. So that means this should be minus 2H plus 7 should be equal to 0. So we move this 7 to the other side, we get minus 7, and we divide by minus 2, so our H should be equal 7 over 2. So our system consistent if our H is equal 7 over 2. Now for number 19, in exercise 19 and 20, choose H and K such that the system has A. No solution, B. Unique solution, C. Many solutions. Give separate answer for each part. So now we have a matrix. We need to solve this augmented matrix, or we need to rewrite it as in the form reduced echelon form or in echelon form. Then we have to choose a value for H and K that make the first case there is no solution, B. Unique solution, and C. Infinitely many solutions. So let us write here 19. So if we rewrite this one as a matrix, we have it is 1, then 4, H8, and here we have 2K. Let us reduce this matrix. So row 2, we can write row 2 is equal minus 4 row 1 plus row 2, and we get our new matrix, which is 1, here H, here we have 2, and for the second row here we have 0, minus 4 row 1, sorry, minus 4H, minus 4H plus 8, and this one we have minus 8 plus K. So this system has no solution if minus 4H plus 8 is not equal to 0 and minus 8. Sorry, this system has no solution if minus 4H plus 8 is equal 0 and minus 8 plus K is non-zero. So first case, no solution. if minus 4h plus 8 is equal to 0 and minus 8 plus k is not equal to 0. That means if we choose, for example, here h is equal, minus 4h plus 8 is equal to 0, that means, for example, is equal to, so that means here we'll get 0. And minus 8 plus k is not equal to 0, choose any value for k, for example, k is equal 1. So if h is equal to, here we will get, it will be, this one will be 0. And if k is equal 1, that means here this value is equal minus 7. So here 0, 0, minus 7, this is in the form 0, 0, b. So our system is inconsistent if h is equal to and k is equal 1. You can choose any value of k that does not make minus 8 plus k is equal 0. So here the system has no solution if h is equal to and minus 8 plus k not equal to 0. That means you can choose any value of k that does not make this one to be 0. So this is an example of one. Now it said here also we need to choose a unique solution. So for unique solution, P unique solution, that means there is no free variable. So we have a value for minus 4h plus 8, and also we have a value for minus 8 plus k. That means we can write here if minus 4h plus 8 not equal to 0 and minus 8 plus k is not equal to 0. Both of them are not 0. Because if both of them are 0, that means we have a free variable. But if they are different, so minus 4h plus 8 is not equal to 0, which we can choose any number. For example, h is equal 1. We get here minus 4h plus 8 is equal minus 4 plus 8, which is 4. And minus 8 plus k is not equal to 0, so we can choose any number different than 8. So for example, let us take k is equal 1. So if k is equal 1, h is equal 1, that's mean here minus 4 plus 8, which is 4, and minus 8 plus k, which is equal minus 7. Last one or last form we have here, many solution. That's mean we have a free variable. So C, that's mean we have three variables. So many solution. That's mean if both of them are 0. So if minus 4h plus 8 is equal to 0 and minus 8 plus k is equal to 0. That's here if we have h is equal to and if k is equal 8. That's mean here we have 0 and 0, so we have a free variable and we have infinitely many solutions. For exercise in 21 and 22, we need to mark each statement true or false and we need to justify our answer. So for the first statement here we have, in some cases, a matrix may be row reduced to more than one matrix in reduced echelon form using different sequences of row operation. This one should be false because according to the theorem, we have only one reduced echelon form. So this one is false because we have only one reduced echelon form. So there is no more than one. It should be a unique reduced echelon form. So here we can false, right here unique. B. The row reduction algorithm applies only to augmented matrix for a linear system. This is also false because we do row operation for any coefficient matrix. So this one also will be false. Now for C, a basic variable in a linear system is a variable that corresponds to a pivot column in the coefficient matrix. Also this one should be true because it is clear. For any pivot columns we have a basic variables. Now for D, finding a parametric description of the solution set of linear system is the same as solving a system, which is also true. It is clear from the processing to find the reduced echelon form or to find the solution set of the system, we see that the row operation finding parametric description or the general solution, it is the same. Now for E, if one row in an echelon form of an augmented matrix is 0, 0, 5, 0, then the associated linear system is inconsistent. This one should be false. Because we say that the system is inconsistent, if we have 0, 0, B. Not this one. This one is, the system is consistent. So this one should be false. The right form should be 0, 0, 0, 5, for example. This one is inconsistent, but this one should be consistent. Now let us see 22. The echelon form of a matrix is unique. This one should be false. We said the reduced echelon form is unique, so here we have should be reduced. Reduced echelon form should be unique. Now B, the pivot position in a matrix depend on whether row interchange are used in the row reduction process. This is what this one is also should be false. So here let us write it A, this one to be B, because there is no relation between the interchange between the row and the pivot position. So here this one should be false. So B, false. Now see, reducing a matrix to echelon form is called the forward phase of the row reduction process. This one also it is clear from the processing, so this one is true. Because the forward process we need to reduce the matrix into echelon form. If we make it in reduced echelon form, that means it is backward phase. Now D, whenever a system has free variables, the solution set contains many solutions. This one should be false. Why? Because the system should be consistent. So first, it should be consistent first. Sorry, it should be consistent first. Now E, a general solution of a system is an explicit description of all solutions of the system. This one is also clear from the solution system, which is a general solution is an explicit, because we write x1 is equal, x2 is equal, x3 is equal, all of them are explicit. So this one should be true. In 23, suppose a 3 by 5 coefficient matrix for a system has 3 pivot columns. Is the system consistent? Why or why not? So here we have 23. For example, if we have 3 by 5 matrix, so that's mean we have 3 rows. This one, 1, 2, 3, and we have 5 columns, 1, 2, 3, 4. It said here coefficient matrix 5, so here we have another row for B's. So now it said if the matrix has 3 pivot columns, so 3 of these 5 pivot. That means our matrix has pivot in every row, because it said it has 3 pivot columns. So for example, the first one, second one, 3, the third one, all of them are pivot. So that means we have a pivot in every this row. Is the system consistent? We can say yes. Why? Because 3 pivot column or pivot in 3 columns, that's mean pivot in 3 column. That's mean we have pivot in every row. That means there is no such, so here we can conclude there is no such row of the form 0, 0, 0, sorry, 0, 0, 8. Because we have pivot in every row, so there is no form of this one, so that means the system is consistent. The system is consistent. For 24, if we write it here, 24, it said here, suppose a system of a linear equation has a 3 by 5 augmented matrix. So here we have 3 by 5, so that's mean here we have 1, 2, 3, here we have 1, 2, 3, 4, and the last one, 5 for B's, because here it said augmented matrix, whose fifth column is a pivot column. So that's mean if the fifth column is a pivot, that's mean here we have 0, 0, 0, 0, and here we have, for example, let us say any number, and here we have 0, 0. So if the fifth column is a pivot, that's mean we have the form 0, 0, B. So if we have the third column, the third row of the form 0, 0, B, that's mean our system is not consistent. So we said here it is no. The system is not consistent. Is the system consistent? No, because we have the form 0, 0, and here we have B. So because the last row is in the form 0, 0, 0, 0, B, which is inconsistent. 25. Suppose the coefficient matrix of a system of linear equation has a pivot position in every row. Explain why the system is consistent. If we have a pivot position in every row, that's mean there is no, so if we write here pivot position in every row, that's mean there is no of the form, there is no row of the form 0, 0, 0, B, for example, because it has a pivot position in the coefficient matrix here. So that means there is no row of the form 0, 0, B. That means our system should be consistent. So the system is consistent. فهو لما يقول عندي في الكوفيشنت ماتريكس pivot position في كل الرو، إذا أنا ما عندي الفورم 0, 0, B. ده معناته system should be consistent. So this is 25. Now for 26, suppose the coefficient matrix of a linear system of 3 equations in 3 variables has a pivot in each column. الحين هنا عندي pivot in each column. Explain why the system has a unique solution. So if the system has a pivot in every column, that means there is no free variable, so the solution should be unique. So we can write here all columns are pivot. That means there is no free variable. That means the solution is unique. Now for 27, restate the last sentence in theorem 2 using the concept of pivot columns. If a linear system is consistent, then the solution is unique if and only if. So if our linear system consistent, then the solution is unique if and only if it is dependent in this one, 26. If every columns in the coefficient matrix is a pivot columns, otherwise there are infinitely many solutions. So we can complete this one by writing here 27. So if and only if every columns in the coefficient matrix, is a pivot column, Otherwise, we will have free variable and we have infinitely many solutions. Infinitely, sorry. Many solutions. So now for 28, what would you have to know about the pivot columns in an augmented matrix in order to know that the linear system is consistent and has a unique solution؟ يعني أنا إذا كان عندي augmented matrix إيش لازم تكون خصائص البيفوت columns على أساس يكون عندي السيستم consistent and it should be unique. لازم يكون كل كولوم بيفوت ما عدا آخر كولوم، لأنه لو كان آخر كولوم في بيفوت في الأوجمنتد ماتريكس إذا معناته بيكون عندي الفورم 00B. إذا في الكوفيشنت ماتريكس لازم يكون every كولوم ماله بيفوت كولوم، لكن في الأوجمنتد لازم يكونوا كلهم بيفوت ما عدا آخر كولوم على أساس يكون عندي إيش؟ يكون عندي system consistent and has a unique solution. So here we can say it for 28. We can erase this part because we need to more space. So for this one, every columns in the augmented matrix except the rightmost column is a pivot or is a pivot column, and the rightmost column is not a pivot column. Or it is enough to write every column in the augmented matrix except the rightmost column is a pivot column. So no need to repeat this one. So that's here we will have consistent system and a unique solution. Now for 29, sorry. So it said a system of a linear equation with fewer equations than unknown is sometimes called an underestimated system. 29. A system of linear equations with fewer equations than unknown is sometimes called an underestimated system. Suppose that such a system happens to be consistent. Explain why there must be an infinite number of solutions. So we have a system of linear equation with fewer equations than unknowns. So that means we have a fewer equation than unknowns. We call this one is underestimated system. We said here suppose our system is consistent. We need to explain why there must be an infinite number of solutions, why we don't have a unique solution. So if we have infinite number of solutions, that means we have free variables. So if we have more variables than the equations, this is from the question. That means cannot be more basic variable than equation. We cannot have more basic variables than the equations. That means there must be at least one free variable. That means there must be at least one free variables. That's why we have infinite number of solutions. 30. Give an example of an inconsistent and estimated system of two equations and three unknowns. So for 30, we need to make an estimated inconsistent system with three variables, with three unknowns or three variables and two equations. For example, if we have, for example, x1 plus x2 plus x3 is equal 3, where x1 plus x2 plus x3 is equal, where x1, x2, x3, all of them are 1. If we have x1 plus x2 plus x3 is equal 3, we have another equation, for example, 2x1 plus x2 plus x3 is equal, for example, let us say 5. If x1 and x2, x3, all of them are equal, so they are 1, 1, 1, so here we have 1 plus 1 plus 1, which is 3. But for this one, if it is 1, so here we have 2 plus 1 plus 1 should be 4, not 5. So that's why this system is inconsistent. So this is an example of underestimated system of two equations with three unknowns, and it is also inconsistent. For 31 في 30 يعني هو يريدني أجيب اللي هي a linear system في two equation three unknowns بشرط إنه السيستم هذا يكون inconsistent. فأنا مثلا لو افترضت إنه الx1 والx2 والx3 كلهم عبارة عن it is equal 1، إذا مجموعهم راح يساوي 3. لكن لو ضربت ال 2x1 في ال1 جمعتها مع الx2 بلس الx3 المفروض يطلع لي 4. هو ما يريد consistent system، يريد inconsistent. على أساس كذا أنا ممكن أسوي هنا 5 6 7 any number. 31. A system of a linear equations with more equations than unknown is sometimes called an overestimated. يعني هنا عندي overestimated و underestimated. Overestimated we have more equation than unknown. Can such a system be consistent? Illustrate your answer with specific system of three equations in two unknowns. يعني لو كانت السيستم عندي overestimated system، هل ممكن يكون السيستم consistent؟ وإذا أيوة ممكن ناخذ example. فخلونا مثلا ناخذ for example اللي هي مثلا لو كانت عندي ويريد example of two unknowns with three equation. لو كانت عندي مثلا نفس الحالة x1 و x2 تساوي لي كل واحدة منهم تساوي 1، لو أخذنا x1 plus x2 إذا معت راح يساوي 2. لو مثلا طرحت ال x1 minus ال x2، طبعا على افتراض أنه ثنتينتهم هذه 1 و 1، إذا 1 minus 1 إذا 0. باخذ the third equation مثلا 3x1 plus مثلا 2x2، بما أن أنا قلت كل واحدة منهم عبارة عن 1 إذا هنا لازم يطلع لي الناتج 5. الحين عندي هذا overestimated system consistent in which إنه x1 تساوي لي x2 تساوي ال 1. That's it.